Greetings. This is chapter 15, part 3. We have two other ways that we can dissolve zinc hydroxide. One of the ways is to add ammonia to the zinc hydroxide solid, and this will magically make it disappear. Now, the reason why is because zinc can form a complex ion to the zinc ion complex to form this. Yeah, I got some problems with the subscript, so let me fix this here so it's accurate. Okay, so 4 ammonia molecules will coordinate to the zinc ion, creating this soluble zinc complex and kick off the hydroxides, okay, into solution. And remember that the Kf, for the formation constants of these complex ions, is so huge that this equilibrium is probably going to be quite large and lie to the right. Another way that we could dissolve zinc hydroxide is to add extra hydroxide. And if the pH is sufficiently high, the excess amounts of hydroxide will cause this equilibrium to shift to the right quite dramatically, okay? So let me show you how we would calculate the equilibrium constant for, this reaction 1. So first, you need to recognize that we have a solid going to ions. So here we would take our solid substance. The only way that I know of to make this dissolve is to, show the ions over here on the right. And we call that the KSP for the or the solubility product for this reaction. Okay, so I'm not too concerned about what that number is right now. But we have solid on the left and we have the 2 ions on the right. And notice how there's a 2 there, so we have a coefficient of 2 on the right-hand side of this chemical equation. And now we want to focus our attention on the ammonia bit. So ammonia can react with zinc ion to form this complex here. So zinc ion can react with 4 ammonia molecules. We know it's 4 because of that little subscript there. Ammonia is an aqueous molecule. It can also be a gas, but in solution it's got to be aqueous for this reaction to occur. And we form the zinc tetra ammonium ion complex. Okay, there's no hydroxide in this formula. There's just zinc ion, 4 ammonias, and then this complex. And the equilibrium constant for this process is Kf. Now, you'll see how we can just, quite straightforward, like add these 2 equations together. When you add these 2 equations together, you can see that zinc ion is, one of those is on the right, and zinc ion, one of those is on the left. They will cancel out. And so to do this, you just put all the reactants on the reactant side of the chemical reaction. So that's zinc hydroxide, your 4 ammonia molecules. And on the right-hand side, we would have zinc ammonium ion and 2 hydroxide ions. It doesn't matter if you write hydroxide first or last, just make sure they're both on the right. The equilibrium constant for this net reaction would be KSP times the KF, okay? And I could go to my tables and get those numbers and plug it in on my calculator. All right, I'm not going to do that here right now. Okay. The you try it problem is this second question. So, what is the K for that? Go ahead and determine that and enter that into your video check for extra credit if you like. Thanks for watching.